chapter review for Integrated 2, Chapter 6. So if I have any type of polygon, it could be a triangle, anything with 3 sides or more, polygon. So if I have a polygon and the sides are 2 to 3, so 2 to 3, I'll write an expression in terms for the measures of the 2 sides in terms of x. So basically what that means is our scale factor. What can we, if we scale this by anything, if we grow this, we have to grow it proportionally, right? So if whatever I times the 2 by, I have to times that by the same number. So if I times the top by 2, I have to times the 3 by 2 as well, right? So whatever I times it by x, then I have to times the bottom by x as well. So I can write that ratio of 2 over x over 2x over 3x. Or I could just put an x here and an x here. That's fine too. Okay. All right. If you have 2 triangles, HJK and triangle RST, and they're similar, that means that their angles, their corresponding angles, are congruent and their sides are proportional. Okay, so you can draw 2 triangles if you want. You don't have to, because we can match up our angles. K is the 3rd letter on the first one, so that must match to the 3rd letter on the second one, so that's angle T. Okay, same thing is kind of true with the proportion, except for the top, whatever's on top would be the same, that would be the same from the same triangle or from the same polygon, and the bottom, the 2 on the bottom, would be this from the same polygon as well. So ST, side ST, from S to T, and R to T, R to T, that side, those are from the same triangle. So then KT, or sorry, JK, JK, and this one that's a blank that we're supposed to fill in will come from the same triangle. So to go from R to T on this bottom one, RT, those two, that's the first and the last. So that means this one must be on this triangle that's going to go on top, also must be the first and the last. So those two, so HK. But which one came first? R. Well, what matches up with R? H does. So HK. So this is going to be HK. So the bottom and the top, whatever's on top comes from the same polygon, and whatever's on bottom comes from the same. But the top and the bottom, those are going to be from the 2 different ones. So the top is from one, and the bottom one's from a second one. That's how you can usually match them up. You can switch these in a way, right? But that's easy just to remember, is whatever's on top is from one polygon, whatever's on bottom is from the second polygon. And then the 2 tops are the same, and the 2 bottoms are from the same polygon. Okay, so hopefully that makes sense to you. If it doesn't, come see me. Or you can YouTube it, or you can do Khan Academy, look up similarities, because they would be in there. Okay. Okay, so now solve this proportion. This one's easy. Whenever we just have a plain variable here, then it's easier to solve for. Whenever we have a variable with something, or we have 2 variables, it takes a little more. But we're just going to solve this proportion by taking the cross product. But this one, this first one, number 3, we don't have to do the full cross product, because the cross product is multiplying our 2 means and then our 2 extremes, right? Which I can't see those numbers anymore. So I'm going to multiply 5 and 5, so that's 25, and I'm going to set it equal to multiplying x plus 2 and 8. Well, when I multiply x plus 2 times 8, that means I have 8x plus 2's. So that means I have 8 x's and 8 2's, which is 16. Now I can solve this 2-step equation, subtract 16 on both sides. So that's 9. 9 equals 8x, divide by 8. There's my x, 9 over 8. X equals 9 over 8. And if you want a decimal, that's fine, but that's good. And you could check that too. Make sure it works. You could plug it in, right? If I plug it in, timesing by 8, the 8's are going to cancel. I get 9 plus 16 is 25, so it works. This one's a little bit easier. All we have to do is just multiply the 2 means. So I just have to multiply the 2 means there, because to get rid of dividing by 15, I multiply by 15, and if I do it on that side, I have to do it on this side as well. And these cancel out because I'm multiplying by 15 and dividing by 15. This 15 right here that I'm multiplying on the right, that is only times by the numerator, as you can see by multiplying the 2 means there. So you can do 2 things. I can take 45 times 15 and figure out what that is, and then divide by 75, or actually three things. Or I could take 45 divided by 75 and then times it by 15. Or finally, I could take 15 divided by or 15 divided by 75 and then times it by 45. Anyway, you're still going to get an answer of multiplying 45 times 15. I can do it that way and then divide by 75, and I get 9. Or I can take 15 divided by 75 and then times it by 45, and I'm still going to get 9. Or I can take 45 over 75 and then times it by 15. Anyway, I'm still going to get 9, and you can check that answer. I can take 9 over 15, reduce it, so 9 over 15, and that is 3/5, and I can take 45 over 75, and I get 3/5, so it is correct. All right, to the nearest inch, a door is 75 inches tall, so draw a door. There's a door, and it's 75 inches tall and 35 inches wide, so draw it out. Okay, what is the ratio of the width to the height? So width, and these are both in the same, you got to check, make sure they have the same units, so that's good. Ratio of the width, so I want to write the width first, and I'm comparing that to, that keyword there, so I can put the word 2 here if I wanted to the height, so 75. So I can leave it like that, or I could write it as a fraction, or I can write it like this, 35 to 75. But it probably wants in the simplest terms. So I just need to reduce that fraction. So what I can do is I can either, they're both by 5, so I can divide these both by 5s. So that'd be 7, divide that by 5. I think that's 15. 75 divided by 5. Yeah, it's 15. So that's the smallest form I can do. Or I can just type in 35 divided by 75, and some of your calculators will actually reduce it for you. But so there's my ratio. I could write in the 3 different forms if I want to. So either way, but reduce. Reduce. So make sure you reduce. Okay. Next one here, in these exercises, we want to know, are they similar? If yes, write a similarity statement. A similarity statement is basically what this thing is right here. That's a similarity statement. Okay, you got to match up angle with angles, and then you put in the tilde, the similar symbol. Okay, so in order for them to be similar, they have to have 2 things. First, those angles need to be the same, is one way, so 2 of the angles at least. So we can use that one, or we can use side angle side similarity, or we can use side side side. The only time we're going to use 3 side similarities is when we have all 3 sides labeled for us. Okay, and we can see here that, hey, this side is 10, this side is 15, this side is 6. So we have all 3 sides. So that means we're probably going to go with Sss Similarity. Okay, so we want to match our angles. Okay, so you might have to redraw these so they kind of look the same. So I'm going to redraw the small one. So the small one's going to look something like this, right? So the Q is going to R because that's the short side. Well, this is the short side, right? It's the smallest number, 12. It's the short side. 6 is the smallest side, so this would be 6. So this would be R, and this would be Q. And then the long side is 30. Well, the biggest number here on the small one is 15. So that's the long side. And so that would make this U. And then the other one is just 10. Okay, so now we can match up our side, side, side. So I write my ratios of the sides. So I can just start with smallest, medium, largest, right? Because remember, it comes from the same shape, goes on top, and then the corresponding angles go on bottom. So that means that what matches up with 12 is the smallest, so that'd be 6. What matches up with the medium one, that'd be 10, and then 15 is the biggest. And then you just reduce this. So the answer is 2, right? That's our scale factor. Scale factor. And then, so that shows that part. So that's our first thing, or second. Or actually, oh, that's all we need for side, side, side. So side, 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 similarity, that means that, or by that, we can say this triangle, say VTU, is similar to, now I just have to match my angles. What goes with U, or V, that's a V. What goes with V is Q. What goes with T, that is R. And what goes with U, oh, this is an S. I'm sorry, you're probably way confused. That was an S. S. So what goes with U is S. Sorry about that. So that's my similarity statement for number 6 there. So that was number 6. Okay, number 7, I'm matching up these. So basically, if you flip this one over, it corresponds to A, and if you flip this one over, it corresponds to B. Well, all we know from this is that C is congruent to this C. So all we know is just one angle. All we have is one angle, right, as 90 degrees. So all we have is one angle. We don't have any sides given to us. We don't have two angles, so this is not similar. Not similar. Oh, no angle. Jeez. No similar. Only one angle is, we'll say congruent because it's 90. They're both 90. Is congruent. And you could use the symbol for congruence too, instead of using the word. So there we go. Not similar, and I need to explain because only one angle is congruent. So we don't have two angles and we don't have any sides. Okay. Third one here. Okay, so here's a little bit tricky. We have this big one. So we have triangle K, say JH, and then we have this smaller one in here, KLM. Triangle KLM. So now we have our angles kind of matching up here, and we want to prove that this is similar. Okay, so we notice we have some sides here, but I have this side. Actually, my green one is just this 4 right here, right? So I have that side, and that would match up with this side from J to K is both of those. So from J to K is actually 7, and then the corresponding one would be from K to L, and that is, maybe I should do that in green, K to L, and that is 4. Right, so we have this ratio of 7 to 4, so we want to see if the same side would match up to that. And so the H to K is both of these again, that's 7. And then we have the small green one, which is just 4. So again, that's K to M. Actually, I probably should match up my angles, right? So that'd be M to K, actually. And that is 4. Well, like the first one, we have our sides, but we don't have all 3 sides, right? I don't know what HJ is, nor do I know what ML is, so I can't use the 3 sides one. But I do have 2, so that would lead me to this one right here. And those are the same, right? So we have 2 sides, we just need an angle in between. Well, the angle in between, if you think about it, which ones do they share? Well, if you look at the letters, they share that K, right? They share this K. So that's the letter. So angle K is congruent to angle K. So by side, angle, side, I have a similarity. So I can say these 2 triangles are similar by side, angle, side. Because I have 2 sides that are proportional. They have the same proportion. And they have an angle in between that's congruent. So that's how you prove that one. All right, so look at this, finding geometric mean of each pair. So geometric mean, remember, is finding the means. You can set it up as a proportion, but you don't have to. It's just kind of the longer way. And you put 4 up here and 25 up here. These are our 2 extremes. These are our 2 means. So you multiply, take the cross product, x squared equals whatever 4 times 25 is. It's 100, but I don't really care. Okay. And then to get rid of the square, do you square root? So when I square root 100, I already know that answer. That is 10, right? So that means that x equals 10, which is the geometric mean. So that would be 10. Or you can just square root these individually. Square root 4 times the square root of 25. Square root of 4 is 2. Square root of 25 is 5. 5 times 5 is 10. So either way, you get the same answer. So basically, you just have to multiply the numbers. So you multiply these two numbers, and then just take the square root of it. So 9 times 12 and take the square root. You can multiply if you want and find the square root, or you can just square root them separate. So I square root 9, I get 3. I square root 12, I can't square root 12. I have to break that down. So that is 4 times 3, and the square root of 4 is 2. So now I have a 3 on the outside and a 2 on the outside. And then I have this 3 on the inside, right? So I don't know the square root of 3, so this becomes 6 root 3. So there's your answer for that one, 6 root 3. And then I have 2 and 8. I want to square root those, 2 and 8. Can't square root 2 and square root of 8. So this one's kind of easier just to multiply, right? Because you get square root 16, you know square root 16 is 4. But I could square root 2 and break 8 down to 4 root 2. And then I know the square root of 4, that's 2. And then here I have a root 2 and a root 2. Well, root 2 and a root 2 is square root of 4, and square root of 4 is 2. So there's another 2. And 4 times 4, or 2 times 2 is 4. So there's my answer, 4. Here's my answer for that one, and here's my answer for this one. Okay, now setting up this proportion. We want to complete this proportion here. So if you want to, you can redraw the triangles. There's 3 of them here. And I always start with the right angle. So we'll do that one, the medium one. Big one, and then we have a small one. So the right angle of the big one is actually right here. So maybe I should do colors, right? So the big one is right there, and that is A, E to F. Okay, let's switch a color. Let's actually do blue. The middle one, the right angle is right down here. That's connecting C, small side C, and small side C. So that would be small side C, and long side D is actually my long side because it matches with E. And then the hypotenuse of the medium one is E. Okay, so let's draw that one. And then we have this small one. The short side of the small one is B, this side. And then we have the long side, which is C. And the hypotenuse you can always tell is from across from the right angle. Here's my right angle. If I have a right angle here, that means I have a right angle here. So across from right angle is the hypotenuse, so that is A. And let me change the color of this one. This one's blue, right? Now I can write these proportions. So B over C. So we have B over C. Remember, these are from they're different triangles when they match up like that. So actually, B goes with C. In most cases, they'll be written. We can change them around a little bit. Right, we can flip that fraction, then we can have to flip this one. Okay, or we can flip the diagonals. All right, so B of this one would go with C of this one, and then I start out with the bottom one. So C came from this second one here. This second one here. So then D is on bottom. So what goes with D is C. So C is right here. Okay. Then for this second one, I have B over A. So this is the only B I have. And the only A I have is actually right here. So it's doing the same triangle, right? So B over A is short side to hypotenuse. And then on top here, I have the hypotenuse. So since I have the hypotenuse, we can compare the same triangle. Because my first fraction was from the red triangle. And A is only with this small triangle. So I have to stay on this same triangle. So that is just going to be back to B. Basically what this is saying is if I take this fraction, I can just flip it. And it's the same as A over B. So B over A is the same as A over B, because you can just flip the fractions. Okay? All right, so that's it for that one. Okay, what is the proportion that has a means of 9 to 10? So means go bottom left, and top right, and extremes go to the top left and the bottom right. So you can set it like that. That could be your answer. Uh, so there's your answer right there. Or you could switch 15 and I could switch these places, 15 and 6, or I could switch 9 and 10. They could switch places, right? As you can see from this up here, this problem that we just did. So notice how these both have C's. That's because they could switch places. Or these both have A's, so they could switch places. Or these have both B's, so they can switch places, right? B is B and A is A. All right. Prove two isosceles triangles are similar. You only need to show that the vertex angles are congruent or a pair of corresponding bases are congruent. So prove any two isosceles. So if I start with an isosceles triangle, so that means that these two sides would be the same, two of the three would be the same. So I have two of those, right? So that means this angle, whatever this angle is, this angle would be the same. And whatever this angle is down here, so say this is y, this would also be y. And then two vertexes are the same, pair of congruent angles. So what it's saying is, in order to prove that these two are similar, you only need to show that the vertex angles are congruent. I'm talking about vertex angles is right here. So if I show that these two angles are congruent, then these will be similar triangles. Okay, so if I say this is 50 and this was 50, they are the same, that means that these two would be similar. Well, how do you know that? Because if I know this is 50 plus x plus x equals 180, so that's 2x, and subtract 50 from both sides. So 2x equals 130. Well, if we do this triangle, I would do the same thing, except for I would have y's here, right? So I add my two y's, I get 2y, and set it equal to 180. Oh, I switched it to x. Oops. That's a plus. Now I subtract 50 from both sides. 50 from both sides. Geez. 2y equals 130. So if I divide this by 2, don't I get 65? X equals 65. If I divide this by 2, don't I get y equals 65? So if x is 65 and y is 65, then x is y, right? They have the same number. If they have the same angle, isn't that at least a similarity, right? Actually, all three angles are similar, right? So there, we prove they're similar. These two are similar as long as we have that vertex angle is congruent, or a pair of corresponding bases are congruent, or if they say, okay, these two sides are similar, then you can also prove that as well, okay? Because then you have, you could probably do side, 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 or something like that. All right, figuring out how to complete this proportion, each proportion. So again, you could redraw these, right? We have the big one. So we have the big one. So this side, this big one, is A plus B plus C, and this one is F plus E plus D. And then we have this smaller one right here down. Well, that one is B plus C, and this one would be E plus D. And then we have this even smaller one, which is just C over D. Okay, so those are my sides, so it wants me to figure out these proportions. So I have A over B. So, oh, so I have those, but I can use, what's that? I think it's the corollary of the side splitter theorem. I think that's what it's called. Basically, I can just match up these proportions. Sorry, I probably didn't even have to do that. But it doesn't matter. I'll show you how to do it. So yeah, you don't even need this. Just wasted a minute or two. Sorry about that. Okay, so I can take anything. I take A over B. So if I start with this side on these two, then I have to start with this side as well, right? So if I start with A, that means I have to start with its corresponding other side is F. So F over E. So this would be F. Okay, then basically what this does is, so it does C over AB. So here's AB together, right? So that's on bottom. And I go with C. So I'm comparing C with these two. So C over A plus B, because that's this side of that kind of red one in the middle of there. And then, so if I started with C, that means I have to start with the corresponding D. And then what matches up to A plus B? That's F plus E, or E plus F. So B would go on top here. All right, sorry about that. Drawing those took a minute of your time. I'm sure you've never wasted my time before. And I'm sure I've never wasted your time before, so I guess we're even. Okay, what is the value of x in the figure? So we can set up our proportion. So if I start with x, usually I always want to start with a variable on top. I can go 24, or I could do, 24, or I could do x over 6. But if I do x over 24, that means I'm going this way. So that means I have to go this way. I have to start with 6, same triangle, over 8. So I could do that one. Or I could do x over 6, so I could go this way. That means I have to go this way. So if I start with x, I have to start with 24. And we can see that this is actually, when I multiply these two, it's the same thing, multiplying these two. So I take 6 times 24, and then I just divide by 8. So I take 6 times 24, 6 times 24, and then divide by 8 is 18. So x equals 18. Or you can take 6 over 8 first and then times it by 24, or take 24 divided by 8 first and then times it by 6. You get 18. There's x. All right, so here's another part of that corollary, or whatever. So we're doing A and B, and these are actually A and B. They're actually not the sides. These are actually the angles in here. So that might be a little bit confusing, but they're actually the angles. So those letters are actually the angles. So A to B is actually talking from this side right here. So that side over, I'll use a different shape, AC. This whole thing, AC. Well, if I start with AB, then I would go here with XY. And then, of course, that would be this one, XZ, which you can see is there. Okay, next one, might as well just draw it again real quick. These lines have to be parallel. So A, B, C, X, Y, Z. Okay, so A to B. So again, A to B. And I'm matching that with XY over here. That's the same as BC. So if I do BC, that means I have to do YZ. So this is YZ. Okay, done with that. Okay, so what we got here is we got two figures. We got this original, which is actually the dashed line. So this one, if I can draw it, with the side of 7. And then we have this bigger one. This is what, so we have the dashed line's the original, and the big one, side's 10. I'm going to run into that one. I'll try not to. That's off shape, but whatever. So is this a reduction? Am I taking, when I'm going from blue to red, is that a reduction or an enlargement? And then what is the scale factor? And remember, we can always take the scale factor n and take, it is the new divided by the old. Okay? So it's the new divided by the old. Okay, so there's our scale factor right there, 10 over 7. So if I was writing this, it would be D 10 over 7. Okay, so there's my n. There's my scale factor is a reduction. I'm taking the blue one and turn it red. It's an enlargement. So that was number 6. Okay, number 7. Take this point and do a dilation of 3. Well, that all we have to do is just take P, take that 3, this point, this x, and times it by our scale factor. So maybe I'll label this scale factor as 3. So this is my scale factor 3. And then take this y value and multiply it by the scale factor, which is 3. So I get 9 over 33. So P prime is the new point. Okay. Well, Or you can just say this equals 9 over 33. That's fine too. Okay, this is by 4, so I just multiply those by 4. So that was 7. This is 8. 8. So again, I just take that point times the 2. This would be prime. 2 by 4, because that's my n, that's my scale factor. And I take negative 4 times my scale factor. So I get 8 over negative 16. There's my new point. All right, done. Okay, number 9 here, I don't know what theorem 7.3 says, but this right here, this angle trisector theorem is this kind of shape right here. It just says that these are proportional. So x over 9 is the same as 12 over 15, or x over 12 is the same as x over 12 is the same as 9 over 15. So it's basically saying why is this not true? Why can I do x over 9 equals 12 over 15, and why can I do x over 12 is equal to x over 12 is equal to 9 over 15? Why can't I do this one? Why can't I do x over 15 equals 9 over 12, which some people did on, I think, their quiz, and they got it wrong. That's because I can switch my two means here. My means can switch places. That's fine. They just switch places because they're still being multiplied, right? That's fine to switch just from section 1 that it tells us. We had those properties, right? We can switch those, but we can't switch 12 and 15. We can't switch their places. So we can switch means, or we can switch extremes, x and 15. That's fine, but we can't switch extreme with mean. Okay, that's why. Yeah, I don't know what this theorem 7.3 is, so I can't answer number 9. That means you don't have to either. Okay, so that's it for this video. So these are kind of the concepts that are going to be on the test. Not exact same problems, or not just changing the numbers either. It's the concepts that are going to be the same. The only thing that wasn't on here was from 6-7. And 6-7 was our dilation, kind of like what we did up here to those points. We just multiply them by our scale factor. Or you can go backwards and just divide, right, to find your scale factor. If I have the first point, what was that, 3, 2, and I have the second point, say 6, 4, then I can just go backwards and I can take my new, which would be 6, and divide by 3 to find my scale factor. So my scale factor is 2. Or if it says move left so many units, then I can just, if I move left, then I just subtract from my x, whatever that unit is. So if I move left 2 units, then I would take this point and I would just subtract 2 from my x, so it would get 1. And then if it says move up 3 units, well, then I would add 3. Up I add to my y, so I'd add 3 to that, so I get 5. So my new point would be 1, 5. If it says move left, then I subtract from my x. If it says right, then I add to my x. If it says down, then I move down, I subtract on my y. And then my scale factor is still the same. So that's the only thing that this kind of didn't cover, was that section of moving left and right on your scale factor. But it did cover dilation. All right, that's it.